Okay, here we are again. We're going to look at elementary data analysis part 2. When we look at one of the levels of analysis, for example, univariate analysis, a univariate analysis is the examination of only one variable at a time. For example, if you were to say the juvenile delinquency rate in Macon County is 4%, there's no independent or dependent variable present, so then this would be a univariate analysis. Because in this example, you have no cause, your independent variable, or effect, your dependent variable. You're simply reporting, a statistic. Now, reading bivariate crosstabs, and let me also pause at this moment and let you know, with this particular segment of the video, you may have to watch part 2 again and make sure you take notes. Feel free to pause at any time so that you can read and review the information that is presented here. With bivariate analysis, a bivariate analysis is examination of a relationship between two variables, your independent and a dependent variable. Your independent variable is sex in this particular example, and your dependent variable or your row value variable is income. The cells of the table show the joint outcomes of the two variables. The numbers, now this is very important, the numbers in parentheses are frequencies, count. For this purposes of this class, we will always analyze percentages, not frequencies. Frequencies are only used to compute percentages. And what the percentages do, it standardize the frequencies so that the cells can be, and these are cells, 1, 2, 3, 4, these are your cells, can be directly compared. These are your percentages, these are your frequencies, or your counts, and your frequencies and your counts do not matter, only percentages. The row marginal, well, is what this is. It's considered univariate because it only measures one thing, total number of respondents, and respondents being the people who responded to your survey or questionnaire. The numbers to the right of the table are always going to be your row marginals, and the numbers at the bottom are going to be your column marginals, those down here. And how do you compute your percentages? Well, you take your frequencies or your counts and you divide them by your total number of respondents, and that will give you your percentage. See how easy that is? Always percentage down. And with multivariate analysis, you're looking at several independent variables. For this particular example, the race of the victim was a control variable, while the race of the suspect played a difference whether or not the suspect received a death penalty. Also with this example, regardless of access to a car, teenagers from highly religious families reported having sex less than half as often as other teens. And if you'll notice, once you know how to read these tables, it's fairly easy. There are 4 rules for interpreting crosstabs. I'm going to go through them here. You can write this down or pause at this point if you'd like. Rule 1. Always put the independent variable across the top of the table. That is, the values of the independent variable will form columns. These are columns. And your dependent variables will always form rows. And in SPSS, always enter the name of the dependent variable first, then the independent variable, then the control variable. And if a table is percentage down, read across so that you can compare categories of the independent variable. For in this case, a higher percentage of respondents have high incomes, or a larger percentage of males have higher incomes compared to females. And believe it or not, that's all there is to reading bivariate, multivariate tables. And remember, independent variables are your columns in SPSS, causes a change in a dependent variable in SPSS, and it isn't possible that dependent variables could cause a change in the independent variable. And that's it for my 5-minute lecture. As always, ask questions and see you in class.